Hello, today I'm going to do something spectacular. I'm going to write a Hello World application. Okay, there's nothing there, so I can open hello.c. And you've probably seen this before. Standard IO.h. This is for printf. It's in standard IO. And then the main function. And just printf a string, hello world, and a new line. Alright, let's open a terminal window here. So now there's the C file, it's 81 bytes, and compiled with GCC. And this is 7.7 kilobytes big, the binary. Examine it with the command file. It's an ELF 64-bit executable because I'm on 64-bit Linux, and LDD shows what it's linked against. This is something to do with Syscalls, and this is something to do with shared libraries, I think, and here's the only library it actually links against. It's the C library, which contains printf and other functions. So let's disassemble it. Object dump, D for disassembly, and the binary. So you see it's a lot of crap in here. But it's the main function that we wrote here, main. And here it's main. So what it's do, push the base pointer to the stack, then move the stack pointer to base pointer. I think this is to preserve these registers and refer to local variables. This is not necessary because we don't have any local variables in the main function. So you could actually remove those two lines, and this pop line too could be removed. So then move an address of some kind, 463C, to this register EDI, and call put S. I had printf here. Compiler was actually so smart, so it translated a constant string here without any arguments, and then a new line into put S, and then return 0 here, move 0 to register AX, and restore the stack and return. Everything else here is just unnecessary code which could be removed. Let's just see what this address contains. It should contain the hello world string without new line. Okay, 63C. It's actually not in here because it ends at 635. So I have to look at other sections. And I think it's in RO data. Let's see. OB section RO data. And the hello binary. Here's the RO data and 63C. Here's 638 9ABC. There's 63C. Hello world, exclamation mark. That's the 21 here, and then just 0, end of string, no new line. You can look at the manual page for put S. You can see put S, just a constant string, and put S appends a trailing new line, and writes the standard out. And actually standard out is always file descriptor 1, so this code could be changed to use write instead. In the section 2 of manual pages are low-level commands, and write is one of those. And you don't have to include standard IO, you can include this one instead. Here, I can remove standard IO and change this to write. First file descriptor and standard out is 1, then the string and count, and I think it's 14 bytes. Backslash n is only one character. Let's compile this. It still works, and now it doesn't use printf, it only uses write instead. If this is the Linux kernel, not very nice, Linux, and here are some device drivers for all kind of devices you connect to computer, like a mouse. Up here are user space programs, like the web browser or whatever. And there is some kind of interface between these two. It's the kernel interface. And when user-space program communicates with the Linux kernel, this is called a syscall. Syscall, and then the Linux kernel answers back the results of the syscall. And this interface is, I don't know, I think it's called application binary interface, maybe. But what's interesting to note, if you're, for instance, on 32-bit Linux, then there are different variants. You have, for instance, interrupt 10 hex on older Linux kernel versions, but on newer kernel versions, it has been replaced by sysenter, and on 64-bit, it's instead syscall instruction. And this is only on Linux. And then if you have other operating systems, it will be different still. And one syscall could be to write a string to standard output. And then the Linux kernel decides what standard output really is. It might be a terminal window or something like that. In addition to UniSTD, you can include sys.syscall.h. Here instead of write, you can put syscall. And syscall what? Syswrite. This syswrite is defined here in syscall.h. And then just add the parameters to write 1 and the string and the length of the string. Okay, it still works. Let's obj dump it. See at the main function. Now it actually calls syscall, but it's still a reference to the C library, so we can't see what this does. But there's a trick. Compile this static. Then it should be included. And the hello should be very much bigger. It's very big. It's so big, so I have to put it through less. And search for the main function. Okay, found it here. What does it do? It sets things up as before, but now calls syscall, which is actually somewhere in here. Let's search for it. Syscall. Here. So what does this do? It calls the assembly instruction syscall, and before calling it, this syswrite is the first argument, puts in AX, second in DI, third in SI, and the fourth in DX. So I have to remember this if we want to write this in assembly language instead. But first, let's generate an assembly file. You can do that with gcc-s hello.c, and now hello.s has been created, and can actually move it to hello.big-s, because big-s is for a file that has not been pre-processed. Let's open it, hello.s. This is what it looks like. Here's the string, hello world. And this is a label referring to the string, can call it wherever. That's just auto-generated label. LC0, here it is. So it's a little bit more clear. And the compiler put in a lot of crap, which can be removed here to make it a little bit easier to read the code. Don't need that either. Okay, and now put some comments. Let's enter assembly mode. Right, and then what? After the syscall, just exit 0. That's what it does. Okay, now let's try to compile this assembly file. We don't have no hello binary, and put the assembly file as input instead. Yep, it worked. Let's try to include some files. For assembly, I think I have to change this to asm/ and I can move this down. Just remove this sys. Then it looks like this. Now, in this syscall.h, those that we use in the C file, this syswrite is defined. So let's just copy this. It should be available from here too. And that should go into AX. let's not call a libc function. Let's call the syscall instruction directly. And then we should move syswrite to AX. And here's the file descriptor, string, and length. Don't need CX. Nope. File descriptor 1, hello goes in there, and length was 14 goes in there. This should work. I'm going to remove the hello and do this again just to prove that it works. Yep, here it comes, hello, and now we didn't call the libc function, we called syscall directly. We should be able to see it in the object dump of hello too. There's still a lot of libc left in here, but this looks better now. And syscall and return 0. Now we can do something even more incredible. If we create an object file instead. Okay, here's the object file. It's only the main function, and if we try to link this, it's gonna complain because it can't find a simple start, because this start is actually in some CRT from the C compiler. But we don't need that. We just want the main function, so let's just rename main to underscore start. Yep, replaced a lot of occurrences. Alright, now I have total control. I don't need this stack thing. We don't have any local variables, so I can remove this pop too. But what are we going to return to? I have to call the exit syscall instead. Okay, just copy these lines instead of this, remove those two, and here call sys exit instead, and move 0 to EDI. Okay, exit 0. This should also work. Now let's rebuild it. Okay, let's see if objdump hello.o. Yeah, it looks exactly right here. So now let's link it. Considerably smaller. And it still works. Okay, now objdump the whole hello binary. Look. That looks good, doesn't it? It's just the start function. And two syscalls. One write and one exit. Let's see what it links against. LDD, hello. Not the dynamic executable. Links against nothing. And file hello. Not stripped. Okay, let's strip it. Strip hello. It's 568 bytes. Let's see if it still works. Yeah, it still works. Pretty small. From 8 kilobytes and linking to libc down to 568 bytes. And not linking against anything, just self-contained code. Objdump. Hello. Here's all of the code. And let's look at the RO data section. I think .ro data. And here's the hello world string at address 40010A. And here's the address move 40010A to ESI. Works perfectly. So this code is actually faster, smaller, meaner, and leaner than writing it in C. Nifty, yeah.